Team, this is a second review for the RC circuits and capacitors. I thought this would be also a good problem to show you. This is why we're reverting back. So in this one, it's saying how much time is required to charge initially uncharged capacitor through a resistor at 90% of its final voltage. And this comes into understanding what the equation V of t equals EMF times 1 minus e to the negative t over RC. One thing to notice is that this line right here actually represents 1 minus e to the negative t over RC. And what this point is telling us at 1 tau, and 1 tau is equal to RC, is that once time reaches RC, then our percentage of the final voltage is 62% of its final voltage. (62% of its final voltage). That's why tau is important, because if you solve for tau, it'll say like, hey, at time such and such, because I multiply resistance times capacitance, I know that my capacitor will be at 63.2% of its final voltage. Now, in this one, it's saying, hey, the voltage is actually at 90% of its final voltage. This is actually saying that, hey, 0.90 of its final voltage equals 1 minus e to the negative, or EMF times 1 minus e to the negative t over RC. It is saying that the ratio between where it's at over the final voltage, which is E right here, is 0.90. So we're looking at around this area right here that is 0.90. And you need to find out what is the time that it takes to get 0.90 times EMF. Okay, so this is a ratio. And that ratio is 0.90 equals 1 minus e to the negative t over RC. Again, EMF, or V of t, actually even better, V of t, yeah, V of t over EMF equals 0.90. That is the ratio. So erasing this, and now let's just solve for time. So just to go through the steps, we have 1 minus 0.90. You can do the math. The natural log, and the reason is because we want to get rid of that e. And that leaves us with negative t over RC. Remember, natural log of e to the negative t over RC is equal to negative t over RC. That is why we do the natural log on both sides. And what we have left is t equals time equals negative resistance times capacitance times natural log of 1 minus 0.90. And that is your algebraic solution for this problem. All right, this concludes the second example, or second review for RC circuits.